Hi everybody, here we are now for Module 5 in CHY 114. Today what we're going to be looking at is some of the dyes that might be coming out from the textile mill. And the first thing that we're going to do is use a couple of different chromatographic techniques in order to first, hopefully, just identify how many dyes might be coming out and into the river from Site 4 there at the textile mill, around sample spot 4 at Site B. And then we're going to use another chromatographic technique to separate those dyes so that we can then do some further analysis to see how much the concentration is of the dyes. And so the first thing to do is to use a technique called thin layer chromatography, or TLC, in order to hopefully identify just how many dyes there are in the river. And so what I'm going to do first is set up my TLC developing tank. So I'm just going to take a little piece of filter paper here, and I've put a little crease in the bottom of it just to make it fit better in my tank. I'm going to put the developing tank, or the paper, into my tank, and then I'm just going to put a little bit of my solvent mixture in here. This is a 1-to-1 acetone ethanol solvent, and that's something that's very important to note in your notebooks. Anytime that we're doing anything with TLC, we always note what solvent we use. And I'm just wetting down the filter paper in my tank. So I got that nice and wet in there. And I want just a little bit more liquid on the bottom. We'll see in just a minute roughly how much liquid I want and what we use to gauge that. That looks about right, just about coating the bottom of the tank there. My filter paper is nice and wet. So I'm just going to cap this so none of that escapes. And so this is the tank that I'm going to put my TLC plate into after I've prepared my sample. And so these are our TLC plates in here. And they've got two sides, one with the silicone media and one that's sort of just a flashy backing for it. And so we're going to be working with this side here with the silicone on it. And so the first thing that I want to do with this is use a pencil, and hopefully some of this was discussed in your pre-lab discussion, so you know why I have to use a pencil. If I can find it, here it is. And so I'm going to use a pencil just to make a small line, roughly about 1 centimeter up or so. So I'm going to make a small line across right here. And that line is where I want to dot my sample, where I want to put my sample. And so in order to, what we call, spot the plate and put my sample on there, I need to use a TLC spotter. These are made from capillary tubes. Those of you that go on to organic chemistry and organic chemistry lab will be making a lot of these little spotters as part of your lab. You'll be doing this type of TLC analysis a lot. You pretty much are running constant TLC in your OChem labs. Then I've got some of the Green River sample from sample spot 4 right here. Now this is very concentrated, and this will be important for us when we are doing our calculations for concentration down the line. But we do want to note that this Green River sample spot 4 has been concentrated by 100,000 times. And so we took some of the river sample and concentrated it down. And so that's why it does appear so green, because some of the dye that was in there is now very, very concentrated. So I'm just taking off the cap. Now all I'm going to do is just dip this down in, and we can see that through capillary action, hence the name capillary tube, you can see, hopefully, that some of the liquid was in fact just drawn right up the tube. Now I'm going to use that to what we call spot the plate. I literally just dab onto the plate until it makes a little tiny spot. Now with TLC, you definitely don't want to over spot. We don't want a large spot here. And I'll hold this up in just a second so you can see it. But I put a little dab on there first, then let that dry, let the solvent evaporate off. And then another little one in the same spot. And all I'm doing is just holding the tube, holding my spotter right down onto the plate. And I do that about 3 times to hopefully get a good spot on there. And so now what we can see is I've got the spot with my sample on my plate. Now this line that I drew, that's gonna be the line that our spot starts from. And I gauged how much of my solvent to put in my tank because I want that solvent level to be below this line. Because what's going to happen now is I'm going to put this TLC plate into my developing tank. The solvent will start out below the line, but then the solvent, as this plate sits in the tank, the solvent is going to work its way up the plate. As it does so, it's going to pick up the dyes that are in the sample. Now, due to differences in the affinity of the dye for the solvent versus affinity of the dye for sticking to the plate, the different dyes in there, if there are different dyes, will have different affinities, and therefore, if there are different dyes in there, they will travel up the plate at different speeds. And so by the time the solvent reaches near the top, and we'll be watching for that, and we'll take this out just before the solvent reaches the top, but then when the solvent reaches close to the top, since the 2 dyes traveled at different speeds, we should, under UV light, see if there are more than 1 dye in there, if there is more than 1 dye. And so let's go ahead and just put this plate into our developing tank. I doubt that I'll be able to do this in such a way that you'll be able to see really. But there, and if you can see that, it moves pretty quickly. So the solvent is now traveling up the plate. And we're just going to let it keep going until it is close to the top. And so now we just sit back and we wait for that to happen. While this is occurring, we could tell each other some nice stories. Let's see if I have any stories to tell while this is occurring. Actually, I will cap my dye while this is happening so I don't spill that and make a mess for someone to clean up. Well, let's see, for a story. This is Easter Sunday morning that I'm doing this. It is little baby Henry's first Easter, and so that was fun. I stuck around long enough this morning so we could open up his Easter basket. And we did that while FaceTiming with his grandparents in Nova Scotia. And so that was a good time. He mostly liked the packaging that things came in. He had a great time playing with the box that his little toy boats came in for the tub. Last night, his daddy might have broken into some of the Easter candy a little bit early and had a couple of peanut butter cups. And so Henry got his first little taste of chocolate too, with a little bit of a peanut butter cup. Let's just say that he was a fan. I can't really think of any other stories to tell right now. Let's see, what else could I tell you while we're waiting for this to happen? I just bought a new car, so that's pretty exciting. Well, new to me at least. For the last 9 years, I've been driving a 2006 Corolla, which I have absolutely loved. It's been a great car for me, but pieces were literally starting to fall off of it, and it was getting to the point that I just didn't necessarily feel safe Again, because of little baby Henry and driving him around. So it was definitely time for something new. And so I bought a 2018 hybrid RAV4 with only 10,000 miles on it. And so trust me, after driving a 2006 Corolla for so long, this feels like a huge, huge upgrade. I've only had it for a couple days, but so far I absolutely love it. Seems like it's going to be a great vehicle. Pretty exciting to have an SUV that seems to be getting around 34 miles to the gallon too, or 30, even pushing 40 miles to the gallon sometimes. So that's going to be quite nice. I don't have any other stories for you. This has moved about halfway up the plate now. I will say that you could maybe even fast forward the video a little bit. I'll stop talking. But at this point, you can probably fast forward until I will probably have it marked on there on the video when you should stop fast forwarding and watch again. But at this point, go ahead and fast forward until the point that I have labeled, in which I tell you to start watching again. Okay, now I think our solvent front has traveled far enough for our purposes. So we'll now take this out of the plate, or out of the tank. And I'm just going to show you what this looks like real quick. So you can see how far the solvent front has traveled. Now when you take a TLC plate out of the tank, you always want to mark pretty much immediately that solvent front with a pencil, because the solvent is going to evaporate pretty quickly and we won't be able to see that anymore, and so we want to know where it traveled to with the line. And so now we will just set this here, let that solvent evaporate and dry off, and then we'll analyze our plate. Our solvent has pretty much evaporated now. So there's a couple things that we can see. First, just visually, there, I think you can see it from there. We can see our two different spots on there. And so that's starting to tell us that at least on a just visual inspection, we have two different spots indicating at least two dyes. We also do always like to look at TLC samples under a UV light. Sometimes the samples that are on a TLC plate don't show up under visible light, and so we look at them under a UV as well. So let's see if I can hold this in a way that you can see it under the UV lamp. So right now this is under UV shortwave, and I'm not seeing any other samples there. Let's look at it under the long wave, and I don't see any other samples there either. And so let's just put our UV away so I can see both of the spots just under natural light. Now what I want to do is to mark the spots in order to do my RF analysis. So I'll just put a circle around each spot here. Remember this line down here, this first one was our solvent front, or was our solvent line initial. This is our solvent front here. And so we want to take down that bit of data. And so we need to measure. First, we measure the distance to our solvent front. So from our line to our front is a distance of 6.30 centimeters. And so the solvent front is 6.30 cms. Now I'm going to measure to the first line, which looks slightly blue in case you, or to the first spot, looks slightly blue in case you couldn't see it in your, in the screen there. And actually a slight adjustment, because I realized that I was starting at the 1 on my ruler, so that solvent front was actually at 5.30 centimeters, not 6.30. And so now the distance to our first spot, which is slightly blue in color, is a distance of 2.35 centimeters. And the distance to our other spot, which was slightly orangish, sorry, once again, not 2.35, but 1.35 centimeters. And the distance to our orange spot is roughly 4.50 centimeters. And that one is real. So again, to recap our data in order to calculate our RF values, the solvent front distance is 5.30 centimeters. The blue spot is at 1.35 centimeters. The orange spot is at 4.50 centimeters. And so this has been our TLC analysis. In the next video, we will look at using column chromatography to separate these two dyes from each other.